Okay, so let's compare. So I talked you through this one here in the lecture notes. So notice how this one goes up to n, right? And so when I'm assuming true for k, I replace the n with a k, right? And then I'm showing true for k plus 1. There's a k plus 1 here. Okay, and I'll let you kind of go through the breaking it up. So when you have up to k plus 1, you break off the first k of them, and then you add on the k plus first term. So this one's a little bit different. So let's, again, always start with true for n equal 2, because that's the first number, right? So I equal 1 up to 2 minus 1, so that's to 1 of I times I plus 1, and then I'm putting in 1 over here. I'm putting in 2 over here, right? 2 here, so I have 2 times 2 minus 1 is 1, and 2 plus 1 is 3, all over 3. So this gives me 6 divided by 3, so that's 2. And over here I have 1 times 1 plus 1, so 1 times 2, 2 equals 2. Okay, good. Okay, so now I'm assuming true for n equal k. So I'm just going to write it here. So I'm putting in k right there, right? So it goes I equal 1 to k minus 1. I times I minus 1 equal to k minus 1, k plus 1, all over 3. Okay, so now I need to show true for n equal k plus 1. All right, so when I'm putting in k plus 1 in here for n, I get k plus 1 minus 1, so this goes I equal 1 to k. So just a little bit difference here. Now I'm going to be putting in k plus 1 on this side, right? So k plus 1 minus 1, that's a k. And then here, k plus 1 plus 1, so that gives me a k plus 2 all over a 3. Okay, so now it's our job to split this up so I can use my inductive step. So this says add all the way up to k. I want to break off the first k minus 1 of them, right? So if you're adding all the way up to 9, I can say, okay, add all the way up to 8 and then the 9th one. So that's kind of what this is. So I'm going to say this here, this right here. So you just work from the left-hand side. Don't even write the right-hand side down anymore. So I equal 1 to k minus 1, I times I minus 1, plus the next term, the kth term, and I don't need the summation, I'm just plugging in k. This is where I use the inductive step. K plus 1 all over 3 plus k times k minus 1. Again, don't write this right-hand side down. Just work this left-hand side here to get here, right? Because you want to make sure you're not working both sides at the same time. All right, so I want to make common denominators first. So I'm going to multiply top and bottom by 3. Never, ever multiply this out because that's going to give you a cubic. That's going to be way too hard to learn how to factor. So look to see if there is anything in common between this term and this term. Yes, there is. There's a k minus 1. So I have k minus 1, and then I can even factor out that 3, right? From the denominator. So if I factor k minus 1 and 3 out of this, I get k times k plus 1. If I factor k minus 1 out of this term, right, with k minus 1 divided by 3, I'm left with 3k. Okay, so k minus 1 over 3. Now multiply this out, add these terms together. So I have k squared plus k plus 3k. So that gives me k minus 1 over 3. So if I add these together, I'm going to run out of room, so I'm just going to do some messy math here. So plus 4k, right? Oh, did I mess up? No, that's right. Okay, so that gives me 4k. So what did I do? I wrote 4x or something there, didn't I? Plus 4k. Okay, so if I factor a k out of here, k, I'm left with a k plus a 2. Is that what I was trying to get to? It is. So don't write this right-hand side down. Just get to it. by doing your steps. And this one here, I'm pretty sure I did that one already with you. So I was going to go and do these harder ones of this one. I was going to do this one here. You had to do this in your group work. Okay, or on the slides. All right, so let's start with, so when you have this less than, just expect it's going to be a little harder, right? So n equal 2, so I get 2 squared is less than 2 plus 1 factorial. So this tells me 4 is less than 3 factorial. True. That's 6, right? Okay, so I assume true, n equal k. So I get 2 to the k is less than k plus 1 factorial. Okay, I'm going to use that, right? Okay, so I want to show true for n equal k plus 1. So I get 2 to the k plus 1 is less than, so if I put in k plus 1 in here, I'll get k plus 2 factorial. Okay, so don't use the right-hand side. Don't even write it down anymore. Just start with the left-hand side and start working with that. So this, I know, can be written as this, and you're looking for it. How can I use this inductive step, right? So this says take out 2 to the k, take this out, and put this in. So I'm going to replace the equal with a less than, and I'm going to put k plus 1 factorial. And then I carry this 2 along, right? Oops, I tried to do that in blue. Okay, so there's this 2 gets carried along. Okay, so look to where you want to go. I want to get to here, so you can't just leap. So you want to say, what do you know? So you don't have to do this. This can be your little thinking bubble. What do I know about k plus 2 factorial? That's k plus 2 times k plus 1 factorial, isn't it? So if I just had a k plus 2 here, I'd be good to go. Well, don't I know that 2 is less than k plus 2? Since k's are bigger than or equal to 2, I do. So I can replace this with k plus 2. So you just want to say that down here to communicate to the person reading your proof. See, that's what I did. Oh, and look at that. That's equal to k plus 2 factorial. I got there. So don't write down the right-hand side again. Just leave it. Okay, so the other one. So this one I showed you was a special trick. And this one I did for you. So let's go do this one together. So this is one I had you do on the Zoom. Make it bigger. There we go. Okay. So true. Let me just write it up here. So true for n equal 2. So I get 2 cubed is greater than 2 times 2 plus 1. So 8 is greater than 5. Check. Okay, so I'm assuming true for n equal k. So k cubed is bigger than 2k plus 1. So I want to show true n equal k plus 1. Okay, so that's k plus 1 cubed is greater than 2 times k plus 1 plus 1. Okay, so I could fix this side a little bit. I could say this is 2k plus 2 plus 1, so 2k plus 3. Don't write that side down again. Just leave it like that. Okay, so at the beginning of this section, I wrote down what k plus 1 cubed is. So you have it in your notes. So if you need it, you can just go look it up. You don't have to go manhandle it. So let me just write this left-hand side out. Okay, so after we write this side down, don't write this right-hand side down again. Just work from the left-hand side. So now you say, look at that. I can use my induction step. So I'm going to take out k cubed, and I'm going to put in greater than 2k plus 1. So 2k plus 1, and then I'm going to carry the rest of it along, right? So 3k squared plus 3k plus 1. Okay, so now you look to where you want to go. I want to get to 2k plus 3. So I'm looking at 2k plus 1 plus 1. I just need this to be 2, right? So think about it. Can I make a statement about this? can I say that this is greater than 2 since k's are bigger than or equal to 2? Yes, I can. So I take this out, and I'm just going to put in, I'm going to carry my 2k plus 1. That's this one, right? And then I'm going to say plus 2. Oh, and there it is, 2k plus 3. I got to the right-hand side.